Hello, good morning, good afternoon, everybody. First of all, tell me if my voice and my video and my screen is visible to you or not. Yes, please tell me if my voice is audible and my screen is visible. All right. Thank you so much. Everybody replied quite positively. So that means the screen is visible to you and the voice is also audible to you. Got it? Okay, this class is being live streamed on the YouTube also. So you don't have to record it on the cloud on your own. It will stream there. You can watch the class again at YouTube. All right. So we have done the limits previously. In last two sessions, we have been doing limits. So just a quick review of limit. So what we will do first of all, recall of limits. Quickly tell me the answer of these four questions. Very quickly, give me the answer in the chat box. Yes. See, answers are already there. I don't know what you are planning to do. We all are aware. I'll write them again. Limit x approaches to 0. Sin x upon x is what? 1. We all know that. Limit x approaches to 0. 1 minus cos x upon x square. I told you to remember this limit. This is equals to 1 by 2. Limit x approaches to 0. Tan x upon x is 1. Limit x approaches to 0, e to the power x minus 1 upon x, 1. And finally, this. Limit x approaches to 0, log 1 plus x upon x is equals to 1. So just as a quick reminder, we have to remember these limits. All right. They will be very frequently used in the questions of continuity also. Now, let's start with continuity. So, see, the very basic meaning of continuity is while drawing a function, you don't have to lift your pen. Got it? There is no hi-fi talks. Just simple thing. If you are drawing a function, you don't have to lift your pen. Like this is the graph of a continuous function. This is the graph of a continuous function. But if something going like this, where you have to lift your pen, that means the continuity lost here. Function is not continuous. So in a very basic simple meaning, continuity of function is what? That while drawing the function, it should be what? Continuous. You should not be lifting your pen while drawing that function. Now, what is continuity in mathematically? Continuity is what? Say this is a function. This is the point x equals to a. So left hand limit at x equals to a should be equal to right hand limit at x equals to a should be equal to value of the function at that point. Got it? So limit x approaches to a minus fx should be equal to limit x approaches to a plus fx should be equal to f of a, value of the function at that point. And this should be a finite known quantity. So limit x approaches to a minus fx is equals to limit x approaches to a plus fx should be equal to f of a, and that is a finite known quantity. I hope I have made my point clear, and very simple thing. So LHL should be equal to RHL, and that should be equal to value of the function at that point. If this is exist, then a function is said to be continuous at x equals to a. Am I clear? Like if I write a very simple function, fx equals to x square plus 2 if x is less than 2. At x equals to 2, it is lambda. If x is more than 2, it is 4x minus 2. All right. Now, if you find limit x approaches to 2 minus fx. So see, before 2, this is the definition. X less than 2 pe x square plus 2 is the definition. So that would be limit x approaches to 2 minus fx is what? X square plus 2. Now put the value of x as 2, you get 6. Got it? Now right hand limit, if I find limit x approaches to 2 plus fx, that is limit x approaches to 2 plus. Now in the right of 2, this is the definition, isn't it? In the right of 2, this is the definition. So what it will be? 4x minus 2. That is 4 to the 8 minus 2, 6. So for this function to be continuous, RHL is 6, LHL is 6. So for this function to be continuous at x equal to 6, at x equals to 2, for continuity at x equals to 2, your lambda should also be 6. Got it? Value of lambda should also be 6. Now, let's talk about something about what are the reasons for discontinuity. Condition for the discontinuity. See, discontinuity may arise due to any of the following situations. All right, what are the situations? Right hand limit or the left hand limit or both may not exist. Say function is like this, that its left hand limit or right hand limit is non-existing. Got it? Right hand limit or left hand limit or both for the function may not exist. So if the limit does not exist, that means function is discontinuous. Or right hand limit and the left hand limit of the function may exist but are unequal. Means left hand or right hand limit, they both are same but they are different. They both are existing. Left hand and right hand limit both are existing but they both are different. Even in that case, we say discontinuity is there. The right hand limit as well as the left hand limit of the function may exist, but either of the two or both may not be equal to f of a. That simple meaning, left hand and right hand limit both are existing. Say, both are existing, but either they are not equal, or if they are equal, they are not equal to value of the function at that point. Got it? They are not equal to the value of the function at that point, or they are not equal on their own. So in any of the case, continuity won't exist. The function will not be continuous. Now, different type of discontinuities, let's talk about type 1 of discontinuity at a point. Now, this is what we call, first of all, let's go with the definition. Definition is the right hand limit or the left hand limit of the function may not exist at this point. Got it? The right hand limit or the left hand limit or the value of the function does not exist at this point. Either left hand limit is not existing or right hand limit is non-existing, or value of the function at that point is non-existent. Like in this diagram, if you see, left hand and right hand limit both exist. They both are same, but value of the function at that point is non-existing. Got it? So this type is also called when LHL is equals to RHL, but not equal to f of a, but not equal to f of minus 1. LHL is equal to RHL, but not equal to f of minus 1. LHL is equals to RHL, but not equal to f of minus 1. In that case, we call it missing point discontinuity. Missing point discontinuity. In that case, we call it missing point discontinuity. that the value of the function at that point -1 is missing. Got it? Now type 2 of discontinuity of second type. The right hand limit and the left hand limit of the function may exist but are unequal. The right hand limit or the left hand limit of a function may exist but are unequal, like this. In this diagram, if you see, right hand limit is this. This is the right hand limit. That is equal to something like 1.8. And this is the left hand limit, that might be 0.3. So LHL is not equal to RHL. Got it? So here at x equals to 1, LHL is not equal to RHL. This is called irremovable discontinuity. Irremovable discontinuity. LHL is not equal to RHL. So this is what we call irremovable discontinuity. Now, type 3 of discontinuity, right hand limit as well as the left hand limit of the function may exist, but either the two or both may not be equal to f of a. Like this particular example, if you see this particular example, limit is existing, but it is not equal to the value of the function at this point. This is what we call jump discontinuity. Jump discontinuity. Here what is happening? LHL is equals to RHL but not equal to value of the function at that point. This is what we call jump discontinuity. All right. Now, these were very simple things. Let's try certain questions over the continuity. Got it? First question is, fx is given as x square minus 3 upon x minus 2 if x is less than 1, and it is x plus 7 if x is more than equal to 1. Got it? Check for continuity at x equals to 1. Tell me quickly your answers. Is it continuous at 1 or not continuous at 1? Yes, tell me. Here, if I try to find LHL, that is limit x approaches to 1 minus fx. That is limit x approaching to 1 minus function is what? X square minus 3 upon x minus 2. So without any doubt, just put the value of x. So it is minus 2 upon minus 1. So it will be 2. And if you try to find RHL, that is limit x approaches to 1 plus fx. Now in the right of 1, what it is? X approaches to 1 plus fx comes x plus 7. The answer is 8.
It's discontinuous, sir.
Yes, yes. Left hand limit is coming 2. Right hand limit is coming 8. So function is discontinuous. Got it? Well, very good. एक छोटा सा नोट डालेंगे. fx equals to greatest integer function. This is what? GIF, greatest integer function. fx equals to greatest integer function is discontinuous at every integer. Fx equals to greatest integer x is discontinuous at every integer. And you are very well aware of, we have also made this graph earlier. The graph of greatest integer x is something like this. Do you guys remember this? And you see, at every integral point, the graph is getting discontinuous. So fx equals to greatest integer x is discontinuous at every integer. All right. Now, with this thought, I will show you how to draw fx equals to greatest integer of sin x. This is greatest integer function. Greatest integer of sin x, x lies between 0 to 2 pi. So now we will draw this graph and count the number of points of discontinuity. Count the number of points of discontinuity. All right. Now see very carefully. In 0 to 2 pi, this is the graph of sin x. In 0 to 2 pi, this is the graph of sin x. Now we are going to draw its greatest integer. Like see, exactly at pi by 2, value of sin x is 1. So its greatest integer will also be 1. Exactly at pi by 2, value of sin x is 1. So its greatest integer is also 1. But in the neighborhood of pi by 2, like in the left side or right side, value of sin x is what? Like this. Less than 1. So greatest integer will become 0. Am I correct? So in 0 to pi, up to pi, value of sin x will always be 0 except at x equals to pi by 2, where value is getting 1. Now exactly at pi, sin x is 0, the greatest integer is also 0. Now right in the right of pi, now sin x start getting negative. If sin x is getting negative, so its greatest integer will become what? Minus 1. So sin x is minus 1. It will remain minus 1 because it will remain negative and it won't go below minus 1. So it will always be minus 1, and exactly at 2 pi, it will become 1. Did you get it? This is the graph of sin x. The greatest integer. The graph of the greatest integer of sin x. Now tell me at how many points it is discontinuous. So discontinuous के लिए if you realize pi by 2 is 1 point, pi is another point, and then 2 pi is another point. So in 0 to 2 pi, there are total 3 points of discontinuity. Total 3 points of discontinuity. Have I made my point clear? So this is the graph of greatest integer of sin x, which is discontinuous at 3 points. Got it? Now, some properties of continuity. Properties of, or I should say, I should not call it properties. This is basically algebra of continuity of a function. Okay, one thing. If I talk about fx equals to 10x. Fx equals to 10x. Now I give you options. A, it is a continuous function. B, it is a discontinuous function. What will be your answer? I'm launching a small poll. You will have to answer in A and B only. So what according to you tan x, continuous function or discontinuous function? Answer from A and B only. All right. Okay. All right. Out of total 9 candidates, 5 say continuous, discontinuous, 4 say continuous. Okay. Anybody who has told me that fx is a tan x is a continuous function, please raise your hand. Anybody who commented that tan x is a continuous function, please raise your hand. Or unmute yourself and explain me why. Yes, anybody of you? Whoever is saying tan x is a continuous function, just speak up, please. Anybody? Now see, basically, tan x is a continuous function. Whenever we talk about the continuity of a function or we talk about anything about any function, we only talk about in its domain. Got it? Praveen, can you please switch on your mic? So, whenever we talk about any function, its continuity, its differentiability, its range, its periodicity, its even odd behavior, anything. So, for a function, whatever we are talking about, we talk about in its domain. Now, tan x is basically discontinuous at those points which are not in the domain, like pi by 2, 3 pi by 2, 5 pi by 2. So, at those points, talking about continuity or discontinuity is immaterialistic. Got it? We won't talk about the discontinuity of tan x at x equal to pi by 2. So, what do we directly write? Tan x is continuous in its domain. Tan x is continuous in its domain. But yes, if somebody particularly asks me, is tan x continuous at pi by 2? Then we will definitely say no. Got it? But if somebody asks, if tan x is continuous at x equals to pi by 2 or not, then the answer is no. No, it is not continuous. Got it? While they're asking about a function at that particular point, then we will give answers according to that point. Otherwise, tan x is a continuous function. Got it? Now we'll see about the algebra of continuity. See, if fx and gx both are continuous at x equals to a, then this is the first point, then fx plus minus gx, fx into gx, and fx upon gx, where ga is not equal to 0, are also continuous at x equals to a. So if fx and gx both are continuous at x equal to a, then just a minute. So if fx and gx both are continuous at x equal to a, then fx plus minus gx fx into gx and fx upon gx are also continuous at x equal to a. Second point, if fx is continuous but gx is discontinuous at x equals to a, then fx plus minus gx is definitely discontinuous. But nothing can be commented. Nothing can be commented about fx into gx and fx upon gx. They can be continuous, they cannot be continuous. And now the next, if fx and gx both are discontinuous at x equals to a, then nothing can be said about their sum, difference, product, or quotient. If fx or gx both are discontinuous at x equal to a, then we cannot say anything about their sum, difference, product, or quotient. Got it? Now let's do a question over it. Question is, a function fx is given as 3x fractional part of x plus greatest integer of 4x. Check for discontinuity in 0 to 2. Means check for the discontinuity at the points in 0 to 2. Okay. Now see, this is fractional part function. This is greatest integer function. Try it once. I give you a couple of minutes. Try it. This will be an integral answer. You may like post your answer in the comment section quickly. Yes, anybody? Now see, this is greatest fractional part of 3x, greatest integer of 4x. So if I talk about this 3x, fraction part of 3x. See, fraction part of function or greatest integer of function, They are discontinuous at every integer in that strikes. This function can be written as 3x minus greatest integer of 3x and plus greatest integer of 4x. Now, this is discontinuous at, I'm talking about first in x belongs to 0 to 1. This is discontinuous at 1 by 3, 2 by 3 and 3 by 3, which is 1. 0 by they both are continuous. Now, at 4x, discontinuous as 1 by 4, 2 by 4, 3 by 4 and 4 by 4, which is 1. See, at 1 by 3, this is discontinuous, this is continuous. So overall summation is got discontinuous. At 2 by 3, this is discontinuous, second one is continuous, so function will be continuous. At 1 by 4, this is second one is discontinuous, but first one is continuous. Similarly, 2 by 4, similarly 3 by 4. All right. Now there is only one point left, that is x equals to 1. There is only one point left, that is x equals to 1. If the function is continuous because at x equal to 1, both are discontinuous. So when both of the function are discontinuous, what did I say? Nothing definite can be said about their sum difference product or quotient. Now we will check using limits. So f of 1 minus, right before 1, what is the limit of the function? 3x will remain 3. Greatest integer of 3x will be 2 point something, means greatest integer will be 2. Greatest integer of 4x will become 3. So answer is 6 minus 2, 4. F of 1 exactly. 1 पे function की value 3 minus 3 plus 4, that is 4. F of 1 plus p, it will be 3 minus 3 plus 4. That is also 4. All right. So it became continuous at x equals to 4. Got it? So function became continuous at x equals to 4. It means because continuous at x equals to 1, sorry. And value of the function is 4. So continuous at x equal to 1. So in between 0 to 1, there came 5 points of discontinuity. 1 by 3, 2 by 3, 1 by 4, 2 by 4 and 3 by 4. So in between 1 to 2, also there will be 5 points. So there are total 10 points of discontinuity. There are total 10 points of discontinuity. Am I clear? All right. Another question. A function fx is given as 2 tan x upon x while x is less than 0. It is 1 minus cos x upon x by 2 whole square while x is greater than 0, and it is 2 if x equal to 0. Tell me about the continuity of a function. A option is continuous, B option is discontinuous, and C option can't say. Yes, tell me. I am also launching a poll. Yes, quickly. Yes, I want more answers. Well, let's end with this. Answer to this question. See, if you check for left-hand limit, limit x approaches to 0 minus 2 tan x upon x. Tan x upon x comes 1, answer is 2. If you check for right-hand limit, limit x approaches to 0 plus, it is 1 minus cos x upon x square. And this 1 by 2 square will come 4 in the numerator. So it is 4 into 1 minus cos x by x square. I just told you 1 by 2. So answer is 2. So your LHL is 2, RHL is 2, value of the function at that point is also 2. So it is continuous at x equals to 2. Got it? Now, try question number 1 quickly. Find what value must be assigned to k so that function is continuous at x equals to 4. Quickly tell me. What value must be assigned to k so that this function is continuous at x equals to 4. Yes. Function should be continuous at x equals to 4. Give me your answer in the chat box. Yes, quick, quick, quick. See, at x equals to 4 value is k. So limiting value at x equals to 4 we have to figure out. So it is limit x approaches to 4, x raised to the power 4 minus 256 upon x minus 4. It can be written as limit x approaching to 4. This is x square plus 16. X square minus 16 can also be further x minus 4, x plus 4 upon x minus 4. This x minus 4 cancels. So it is 32 into 8. Got it? Two 256. So value of k should be 256. That will be your answer. Got it? You can also use L hospital here, which will also be simple. Now next question. Fx is sine of ax square upon x square and 3 by 4 plus 1 upon 4a. For what value of a fx is continuous at x equal to 0? Yes, tell me. The value of a for which fx is continuous at x equal to 0. Option I give you. A option 1, B option minus 1 by 4, C option A both, D option A none. Yes, tell me. Mark your answer in the poll. Yes, quickly answer. Yes, yes. Only 7 people answered as of now. Others also participate. Well, at x equals to 0, value is 3 by 4 plus 1 by 4a. All right, I'm ending the poll. Answer will be A and B both. All right. Now, limit x approaches to 0, sine of ax square upon x square. You multiply by a, you divide by a. So this sine 0 by 0 will become 1. Answer is A. So this is the limiting value. This 3 by 4 plus 1 by 4a equals to A. Now you multiply the equation by 4a. So it will become 4a square minus 3a minus 1 equals to 0. If you factorize it, you get 4a plus 1 into a minus 1 equals to 0. So value of a is 1 and minus 1 by 4. So both a and b will be your answer. Got it? Now, try this question. Question number 3. Fx is a plus 3 cos x by x square. X is not equal to 0. And it is b tan pi upon greatest integer of x plus 3. Is continuous at x equal to 0. Find a and b quickly. Yes, quickly. Now see this one. Limit x approaches to 0. This is an important question. A plus 3 cos x upon x square. First of all, the main matter is that limit should exist. For the existence of limit, if you realize at x equal to 0, its denominator is 0. So its numerator should also be 0 for the existence of limit, because limit will exist only in the form of 0 by 0. If it will become 2 upon 0, what will be your answer? Your answer will be infinite and you will say limit does not exist. So numerator should also be 0. To make the numerator 0, what you will do? You do a plus 3. A plus 3 should be 0. So a come minus 3. Got it? So this became limit x approaches to 0 minus 3 plus 3 cos x upon x square. Got it? So this comes limit x approaches to 0, take minus 3 common. It is 1 minus cos x upon x square. Am I clear? 1 minus cos x upon x square. And this limit at x approaching to 0, we know it is 1 by 2. So answer is minus 3 by 2. Got it? See it once. Now, if I talk about the value of the function at that point, that is f of 0. F of 0 is what? B 10 pi by 3. Greatest integer of 3 will be 3. So b 10 pi by 3 is what? B under root 3. Got it? Now for continuity, this b under root 3, for continuity, this b under root 3 should be equal to minus of root 3 upon 2. Should be equal to minus of 3 upon 2. So b is what? Minus of under root 3 upon 2. This is the value of b. Got it? So this was a simple question of continuity. Got it? I'll talk about another problem. Now see, a function fx is given as x sine 1 by x. If x is not equal to 0, it is 0 if x equals to 0. Now, check for continuity at x equals to 0. Now see, for the function, value of x at x equal to 0 is already given to you, that is 0. All right. Now, what do we have to find? We have to find the limiting value. Limit x approaches to 0, it is 1 sine 1 by x into x. Got it? Now, what some students do, they write it like limit x approaches to 0, sine 1 by x upon 1 by x. So, sine 1 by x upon 1 by x, they make it 1. So, this is what you are not going to do. Got it? So, this is wrong. Now, what shall we think about? We will think about limit x approaches to 0, x sine 1 by x. Now see, this sine 1 by x, this is sine of a very large angle. As x approaches to 0, 1 by x will approach to infinite. So this is the sine of a very large angle, which will ultimately be lying in minus 1 to 1. What it is, we have no idea. But the only idea we have, that is sine 1 by x will be lying in minus 1 to 1. And now you are multiplying it with something which is very close to 0. X is approaching to 0. So some 0 into some other finite number which is not known to us. But answer will be what? 0. So what do we say? It is continuous at x equals to 0. Very, very important question. Got it? I think I have made my point very clear. Now we would like to conclude this class. Continuity